for hosting us. Today we're going to go through about a 10 or 15 minute presentation on the SORT program. And I want to introduce some of the SORT members that are with us. I've got Ken Moorfield here with the red mask. He's a retired fire lieutenant from Olympia and a former McLean Black Lake captain. We've got Mark Hill, who is the team safety officer and a retired captain from Puget Sound Fire Authority, and Lieutenant A.J. Paulson, a retired lieutenant from Lacey Fire. And they're going to assist today with our little orientation to Rescue 91 and Rescue 01. So, just to give you a little bit of history, the first technical rescue in Thurston County was actually done not by SORT, but it was done in 1978 by volunteer firefighter Dick Huntley from the Tumwater Fire Department. And they had a small plane with several occupants that could crash when it was in a tree somewhere near Mills-Sylvania Park. I was on duty that night, heard the dispatch, and they didn't know where it was, but it was somewhere near Mills-Sylvania Park. Dark, stormy night, the kind stories are made out of. And finally, one of the units finds the tree with a plane in it, and Dick Huntley was a volunteer firefighter and worked for the phone company. He was a pole climber. They called Dick up, he brought his climbing gear in, put spurs on, climbed the tree, went up, tied the plane to the tree, used a rope, tied something around the people's waist, and then lowered them out of the plane. Successful rescue. So that's pretty wild. And he was awarded some kind of award for the Tumwater Fire Department. So probably a little known bit of history in Thurston County. The team itself was founded probably around 2006 or somewhere close to that. And Captain Sobel from the McLean Black Lake Fire Department funded most of the training for that, Homeland Security grant funds that we got. We originally had a dozen people, there was 20 some odd, and today we are a team of about 46 members. So with that, we'll start. Team was founded, okay, late 2007, I was close. Today it's made up of 7 agencies from McLean Black Lake, Olympia, Lacey, Tumwater, East Olympia, West Thurston, and Southeast Thurston. That's 46 members trained to the technician level in each of the disciplines that we do. High angle, low angle, confined space, structural collapse, and trench. And then we've got specific personnel certified and trained in tree rescue and then ice rescue. And then all of our members are or will be trained then to support water rescue activities and have at least a minimum of awareness, shore-based rescue training as well. Homeland Security grant funding providing most of the training and equipment that you will see today. The specialized rescue equipment we have is carried on Rescue 91, based out of Station 91, which has confined space, rope, and water rescue equipment. Rescue 01, which is at Station 01, which has structural collapse and trench equipment. SORT 31, which is at Station 31, which has rope rescue and tree rescue equipment. And then Rescue Trailer 34, which is at Station 34, which has all of our support lumber for structural collapse and trench rescue. At the time this was put together, it's about $375,000 worth of specialized equipment. It's probably more than that at this point. We are a USART Type 3 modified team with a goal of being a Type 2. And the differences in the different types of teams are your capabilities and the type of equipment and personnel that you have available on response. For structural collapse, we have operation and technician levels for training. They do braking, breaching, with pneumatic, air, and electric tools. We've got search cameras, which we'll show you today. We've got all sorts of cutting equipment. We're able to set up shoaling systems and cribbing. We've got several types of communications equipment that's hardwired, and then we're set up to run for several operational periods. One of the things that was interesting was one day we had a tree rescue with 3 people stuck in 3 different trees, and most agencies would have to do one rescue at a time. And we had been in the middle of another rescue training drill, and so we responded with over 20 people from the team. And so we were actually able to do 3 rescues at the same time, which was pretty impressive, to have that much manpower and equipment available at one time. In rope rescue, we've got technician and specialist levels. They're trained to do high and low angle We've got line guns, pneumatic and large rubber bands. We've got ropes as long as 600 feet for spanning long distances. Tree rescue, we have about 10 tree rescue technicians. We've got specialized rigging equipment, climbing spurs, and then flip lines to be able to travel safely in trees. We've got backcountry equipment. We've got a Capitol Forest. We go mutual aid in Mason County, and they're actually all the way out to the ocean. So we could go in places where our urban, suburban equipment is just going to be too heavy and too cumbersome to carry. So we've got smaller rope, smaller, lighter weight equipment that fits in small bags. It's wintertime. We've got snowshoes, snow shovels, and probes, avalanche probes as well. So if we have to go into the backcountry, we're able to do that. And we have had to go up to Capitol Forest, like today. There's probably still snow up there. That'll be difficult to get around. Confined space rescue. We've got ventilation equipment, tripods, pre-rigged hall systems, air monitoring equipment, supplied air breathing apparatus, which we'll show you. So it's air that's attached to a manifold, so we can go up to 300 feet and have an endless supply of air as long as someone is swapping the bottles out. Hardwired communications, patient extrication equipment, and non-entry rescue tools. Trench rescue, we've got pneumatic struts from Paratech and Airshore. We've got cribbing, we've got whalers that are particular length, and we've also got commercial ones that were made. We've got trench panels, airbags, ladders, air monitoring equipment, and hand tools. And one thing I will say that on any of these technical rescue calls, beyond just a rope rescue call, we will always have to be supported by at least one fire engine for just the additional equipment that we need, the ability to have water, additional ladders, and things like that, and additional breathing apparatus. So basically, these vehicles are a support tool to support you, the type of incidents that you may have in your area. Water rescue, we've got the ability to take a fire hose and inflate with air and then send it out across frozen bodies of water or actually out in open water. We've got throw bags, dry suits, ice rescue suits, Carlson board, retrieval systems, and then all our personnel. Our goal is to get them trained to operations level for shore-based rescue as well. Team management. We operate under an interlocal agreement among the departments. I'm the operations team leader. John Kaler from Tumwater is the deputy operations team leader responsible for administration. Scott Santa from Lacey is the deputy operations team leader for operations. And then we have a steering committee that's a representative of each of the agencies, all 7 of them. We meet every couple of months to kind of go over things that are pertinent to the team, approving purchases, changing policies, procedures, things like that. Each discipline has 2 to 3 leads, so that when we do continuing education, we don't burn out one person. So typically for each of our drills, we'll have at least 2 of our leads running those drills. An example of some of our training and some of the incidents that we have had. On the far left, this one actually was a District 8, firefighter Churchwell rescuing a boy at Burford Park. He probably got poison oak when he was done. There's a Chris Barney doing a rescue down in Tenino, a man and a dog. Doing structural collapse training with struts in the lower left. Over here we're using a shipping container to practice making raker shores out of wood. And this is our little rubble pile we have at Station 91 doing USAR training for breaking, breaching. You can see the ventilation fan ducting up over there. And then the bottom one doing some rope rescue training at Station 91. We're a Homeland Security team. We are the Homeland Security USAR team for the region, so basically we go all the way out to the ocean if need be. And we provide service for all of those other agencies. Because most of the other areas, once you leave Thurston County, don't have technical rescue. A lot of departments have a rope rescue kit and a Stokes basket, but they don't have structural collapse equipment and trench equipment and confined space rescue equipment. Since 2008, we've had multiple responses throughout the county and throughout the region to show that the team has it was well-deserved when we put it together. For example, and this was actually one of the first tech rescue calls I went on when I assumed my position on the team. This was out in Mason County. This was a well. Contractors knocked down a little outbuilding and thinking there was nothing else there. And the guy was poking around on what he thought was just some old rotten boards. Turns out he was standing on top of a 30-plus foot deep hand-dug well. He broke through those boards and fell in there. And so we had to send a firefighter down and put a harness on him and then extract him out of that. We hadn't really thought about the fact that when we send the firefighter in order to put the harness on him, he's got to be underwater to get the thing strapped up, so that was a little bit awkward. And you don't want to be wearing turnout pants when we lower you in the well. You weigh quite a bit, since water weighs 8 pounds a gallon. So don't send your biggest guy in there. That was a bit of work getting him out. Because we were working right on the edge, when we talked in our rope operations class, you'll notice that all the people working on the edge, they've got cords. That's a little travel limiting cords that will actually get into the space. And you can see the ducting right there, the yellow ducting in the bottom. They're ventilating that space while we're working on getting out of there. And of course, you can't see the photo. It's pouring rain, and there's water running in there as well. An actual trench rescue that we had in Lacey, and you can see the victim is actually holding on to a rope, and Kobe Farnham's holding the board. They're using a Vector truck from Olympia to suck the dirt out from around him. So that was a bona fide rescue. I think initially he was buried over his face. So that was a good trench rescue. Here we've got other incidents and training. Tree rescues on JVLM property. A search we did for a missing teenager in Grace Harbor County. Shoring operations. On the lower right, there's a soldier that was being lowered out of a tree that was rescued. So then over here practicing breaking and beaching with our equipment. There's the team after doing training at the Capitol years ago when the team was first assembled, and of course it's raining. And Ken's helmet still looks like a cowboy hat in his head. More recent picture, that's after the day we rescued 3 paratroopers at the same time. We got a nice little plaque from the Ranger Battalion. And some of these members have left, some of them are still there. There's a young-looking Chris Patty picture. And 2019, 10 minutes after that picture was taken, the team was dispatched to the wind farm down south. We had 2 people that were stuck in a trench. And though I'm a battalion chief now, I was a fireman once at one point. And that's when I was traveling between the firehouse and the ambulance I worked on. Bicycle was the best way to get around back then. Okay, this is Rescue 91. It's based out of Station 91, and this rig carries our rope, confined space, and water rescue equipment. What I'm going to do first is just kind of give you an overview of the compartments, and then we'll walk back and look at some of the specific equipment. So this compartment here has extension cords, tools, it's got hand tools, and our tripod sits in this tube over here. Next compartment over here is our confined space rescue compartment. It's got 150-foot air lines that we call umbilicus that we use for our supplied air breathing apparatus, as well as our hardwire communication system. And we're going to open one of those up and show you what those are like. It's got a portable table for incident management, and it's got the controls for our light tower, which is on top, which has multiple halogen lights that sets up. Most things in these compartments have to be put back in a specific way and then secured. Otherwise, with these roll-up doors, if they're not put in properly, they'll jam. So after an incident, please do help us gather things up and put them back. But before you put stuff in and roll the door down and walk away, make sure one of those sort guys takes a look. Otherwise, it's kind of embarrassing when we go on a call and we can't get the door lifted up. That has happened more than once, unfortunately. This is our other confined space compartment, and it carries our supplied air breathing apparatus in these black boxes. And in these orange boxes we've got a couple of air manifolds that we use to hook up for that. Our search camera is in there. We've got a lockout kit, and then a Sea Snake, which is a little small portable search camera that we can use for small spaces. Next compartment, this is our patient compartment. And pretty much we try to use orange as our color code for patient equipment. You'll see as we go through our gear. So this is our Stokes pre-rig bridle bag over here. This is our scad. This is a half scad. This is a windshield for our Stokes basket, protect the patient's face. We've got a coiled wire ladder. We've got a dog harness. There's a litter wheel down here, fire extinguishers, a bracket for our litter. We've got several machetes so that we don't have to have brush hitting us in the face, or we can clear an area for making an anchor or clearing a spot for the Stokes litter as we're moving it. And then this is a Boothie bag, which is basically a huge tent that goes over a Stokes basket and a couple of rescuers. So in inclement weather, while we're packaging and doing patient care, the patient is protected from the weather while we're waiting for the litter wheel and for a crew to actually do the patient transport. We've got awnings on both sides of this, since we have quite a bit of damp weather in the Pacific Northwest. Inside the back of the rescue, we've got a Stokes basket, backboard. We've got a two-piece Stokes basket that fits in a backpack with a sleeping bag that we can carry out into the backcountry, attic ladder. We've got an inflatable rescue boat. All of our communications equipment is inside here. We've got portable radios. We've got the hardwire confined space communication system. We've got extra batteries and then writing materials for incident management boards. We've got, over here, we've got a couple of LED telescoping lights, nylon dry suits, ice rescue suits, throw bags, PFDs, and all of that support equipment. And then we've got riding positions for two back here with communications, as well as two self-contained breathing apparatus. The step oftentimes is not stored back here, it's in the rig. If we're gonna park and we're gonna be getting in and out of the rig, you definitely wanna put that step on there. That's quite a big step up to make. The rope rescue equipment is divided up to a couple of different compartments. So this is our backcountry compartment. It's got all of our lightweight equipment for going into the backcountry. Whereas we have a main line and a belay line bag that we carry and our packaging equipment. If we're going to go into the backcountry, then our equipment is broken down into much smaller bags. This is our access bag, here's an anchor bag, and then there's also a main line and a belay line bag in there as well. And then in here, we've got a much smaller version of our litter spider and some of our other rigging equipment. This equipment requires smaller rope, so all these ropes are less than 12.5, they're 11 millimeter ropes. This is our true rescue equipment. We've got climbing spurs in here, and then all the small lightweight equipment that we use for that. And then we've got a small portable line launcher that we can use to get a line up in a tree versus the large slingshot that we carry on the truck as well. Oftentimes when we put a line in the tree and we're in the tree, it's out of our reach. So this is nice because we can then reach up and grab that line and then pull it down. Since our arms are only so long. So the guys laugh at this, but this is actually a pretty handy tool to have when you're in the tree. This compartment here has additional rope rescue equipment. This is what we call an Arizona Vortex. It can be used as a tripod. It gives us the ability to have an artificial high directional change, which will facilitate moving rope systems, moving a litter. It fits in a couple of backpacks, so an engine company could arrive and we could give each person one of these things to pack it in, depending where we were going. We've got additional rescue helmets, gloves, harnesses up in here for people that are assisting us that don't have that equipment, extra headlamps, and things like that. This is our main urban suburban rope rescue compartment. We carry all of our ropes in here. We carry 4 ropes, and then down below we have mainline, belay line, anchor, and rigging kit. We'll show you that in just a moment over here. We've got patient access equipment. If we're working in a confined space, and we're going to be working where they have high beams, then this is an example of a beam clamp. We can clamp this on the beam, and then that's our 5,000-pound rated anchor. We've got a BLS kit that fits in a pack, and we've got an auto defibrillator and then additional anchoring equipment as well. Over here we've got our ventilation fan, we've got edge protection, we've got ducting for the fan, we've got pickets for anchors, and then a small saw for taking up in the tree for limbing trees as we're climbing the tree. This is our mainline and belay line bag. Pretty much this is our go-to for everything in the urban suburban area, so out in the fire district. So basically everything that we carry in here allows us to set up a system that goes up and down. We've got pulleys, descent control device, carabiners, and there's a 300-foot rope, and then we've got a belay kit which basically mirrors this as well. If we're working in a place other than the fire district where anchoring might be an issue, on the roof of a building or someplace where we don't have good access for anchoring, we've got additional carabiners, lots of webbing and short ropes in this bag. And if these bags are already in use and we're at a situation where there's multiple incidents, or we know the patient's going to get moved from one place to another and then have to get rigged again, rather than take all this equipment apart, we've got all that equipment in this bag here, and it's a little bit heavy. That's probably got to be at least 50 pounds or more. You might not be able to check this on the plane, but this is our extra rigging bag. It's got all of the duplicates of all that equipment to get that rigged up. Okay, let's go around now, and we'll go back and we'll kind of go through some of the specific equipment. So we're going to do a confined space entry in a hazardous environment, an IDLH, and so AJ is going to be our entrant, and he actually has donned this just so you can kind of see how this works. What he's not wearing right now is obviously he doesn't have gloves and he doesn't have his class 3 harness on, but he's actually got the supplied air breathing apparatus. We wear a supplied air breathing apparatus instead of a self-contained breathing apparatus. One, his profile is much smaller. He doesn't have a big cylinder on his back. He's got a small 10-minute escape model that's on his side, and if the entrance was so small and tight, he could rotate that and he could drop it between his legs to have a smaller profile. He has a constant supply of air coming from this manifold over here that Mark is controlling. Mark is our air systems manager, and he also is responsible for communications. That orange cord that he has is attached to a headset, and that communications cord travels in this umbilicus. So it is an airline, it is a communications cord, and there's a rope in there to support that as well. And all of that will be anchored someplace so that AJ doesn't end up pulling the entire system into the space with him. AJ has communications over here that goes to a throat mic and an earpiece, and his is open. He doesn't push to talk, so that's one less thing he has to do. He can communicate with Mark the entire time, and he's on a constant flow of air. If for some reason this got kinked, and this is super stiff so that it doesn't, but if for some reason this got kinked, cut, or there was a malfunction with the manifold, AJ has 10 minutes of air that he can milk to then get himself out of there to get to a safe point. We carry 2 of these boxes, so the entry team of 2 attaches to one box. The backup team would be attached to another one. And we would actually have air for a patient as well that could attach to either box, and we'll show you that patient equipment in just a minute. Mark, in this example, is the communications air manager, and then another member has another headset, and they're going to be the rescue group supervisor or the entry officer that's working in that warm zone directing the operation. So their cable
is at least 75 feet long. Mark's shorter, it's 25 feet. Mark has enough cable so he can move around and change bottles. We've only hooked up one bottle in the system for right now, but each system would have two bottles attached. When one gets empty, you switch over to the other one, so we always have a constant flow of air. We might say, hey, Engine 81, get me 6 extra cylinders here, and then assist Mark in swapping these out as time goes on. So we always maintain a supply of those. Confined space entry, we're going to monitor the air, and since it is an IDLH, we don't want to just trust one air monitor, so we have several. There's an air monitor that's going into the space with the team, and then we're also monitoring the air from outside, lowering this down. And we've also got a pickup tube that we can use as well for doing the air monitoring. And then this is our bottle for calibration as well. For the patient, an orange bag, and that goes to a respirator. No escape pack, but it's just a regulator that attaches to the patient's face. And in this example here, we're going to show you several things. One of them being a patient movement device that we have called the SPEC pack. So in this case, a crew has gone in, packaged the patient up in the SPEC pack. This is a great device. It's got handles on it that you can use for dragging a patient. It's made for vertical lifting. It's got a stiff board in the back, so it's great for dragging. As you can see, it's been drugged quite a bit. And it's not great if you're the victim that's in it, but for short hauls, it's fine for doing a vertical lift for extracting someone. The way this is set up, so that when the system is pulled, there's strain relief over here, so we don't have to worry about the mask getting pulled off of him. And also, there's strain relief on this hose, so we don't have to worry about the mask. So there's two places for strain relief on this, so we don't end up pulling that mask off of his face. This is a tripod. It's stored in the apparatus. This one actually goes up to 12 feet. Whenever we use it, we try to use it at its maximum height so that we can actually clear an area. If there's we're in a vault or a space where the ceiling is lower, then we can just lower it, and it's adjustable when we use that. Ken, you want to demonstrate how this works for hauling? So Ken is going to demonstrate. We've got a pre-rigged 4-to-1 haul system, and one of the things, if we ask you to help us, when Ken pulls, he's pulling in line with the legs versus out to the side. So he doesn't want to topple the tripod over. We also probably may have people standing on the legs. As he pulls, there's a carrying device, and so that grabs each time. If we wanted to release it, then Ken would haul slightly.
Release the cam.
He tells me to release it. I hold the cam open, and now he can hand over hand lower that back down. Just a little bit even further down. Oh, that's good. And then what I've rigged for you to see here today is, let's say this was a manhole. So we're going to have that large yellow ducting going in for ventilation. Rather than have all these air lines going in there, as people go into space, we use these large not passing pulleys, and that just keeps the edge of our manhole clear, and we can just run them in here and just clip pulleys to that. So these are not passing pulleys, but we use them in this case specifically just as a high change of direction. And then these pulleys have pins that we use for other functions. We just have to remember to put the pins back when we're done. That SPEC pack lives in this orange bag. There again, orange color code, and it lives in that patient compartment over there. So that is it for our confined space entry equipment. These lines are 150 feet long, and then they get placed back in the bag, kind of in a figure 8. When we deploy them, typically we may ask you to assist. If AJ is going to enter over there, then we'll take and deploy 150 feet, depending on how far we know he's going to go. We'll lay that all out, and then we'll have an attendant, and the attendant's job will be not only to make sure that he's donned his equipment properly and is wearing it properly, they'll be there to be responsible to feed line in and to take line out. And that might be one of you that we assign to be an attendant for AJ. Hey, be over here. As TJ's moving, feed him line. If they say, take up line tension on blue, then you'll pull this out. Otherwise, when TJ goes, or AJ goes to come out, he's gonna have like 60 feet of coiled up umbilicus in front of him. It's gonna be awkward, and he's gonna get stuck. So we're gonna manage that going forward and back. The confined space entry is manpower intensive, but then if we've got a vertical problem as well, that requires a lot of people. So we definitely will need several entry companies to support our team when we're doing something like that. Other equipment we have, each of our tech rescue rigs, Rescue 91, Rescue 01, and Sort 31, carries an incident management board. And this is just a generic board. Rescue group supervisor, TR safety, notes of what's going on, who's the equipment person, who's our entry officer, shoring officer, and then we build teams as we arrive. These are all of our sort members, and so as people arrive, we can put them on these team passports to keep track. The train rescue, the train derailment, was a good indication of, hey, it's easy to be overwhelmed. I think Scott Santif was the rescue supervisor, and he said at one point he didn't know who was there. He just started taking pictures with his phone and then trying to write that down. He basically wrote on our incident management board over there, trying to track that. So now, as people arrive, we'll build teams so we know who's going where. Technical rescue is detail-oriented, and there's a lot of information. So for instance, this is an example of a small pocket-sized trench rescue excavation, SOG, and this has pictures of a trench and some of the specifics that one may not remember when they're doing trench shoring. We also have incident management boards specific for rope rescue. We've got them for confined space rescue, structural collapse as well. And then we've got vests. We've got an incident management vest for the rescue supervisor. We've got one for the shoring person. We've got one for the safety officer. We call it the TR safety. Many of the firefighters in Thurston County are trained as safety officers, but the safety officer is going to be a rescue tech, one of the senior techs that actually has an understanding of that rescue discipline, so they can look at a system and say, hey, that's not safe. We need to reevaluate what we're doing with that. So we've got tech rescue vests for each of the positions that we will fill on an incident. Here's a piece of equipment called the talk box. And so what we can do, we could use this in a confined space or a trench or a building collapse or even a rope rescue incident. Rather than use the radios and have to shout, we take the portable box, this can be lowered into a space, or we can give it to someone to take with them. Ken, why don't you go over here? So Kenny is Kenny is at a structural collapse, and he's working on breaking and breaching, and he wants to be able to communicate with me, and he needs more equipment. So he can get on there, he can call me.
Hey, Andy, can you bring me some struts?
Copy that, some struts.
I need 24-inch.
24-inch strut, copy that.
So this is on all the time.
So it's on all the time. I press the talk. Now, if there's a problem, one of Kenny's guys gets hurt, something collapses, the air monitor goes into alarm, and he's unable to call me, he just pushes the emergency button on there. That resets that. Hey, now we know there's a problem. So this is actually a pretty handy tool. We probably don't use it as often as we should. We end up shouting back and forth, and we're trying to use the radios. So anyway, this is the talk box. A lot of our equipment looks the same, even to our own folks. So they're in similar types of cases. So when we put stuff away, it's labeled. And we finally got smart. This is one that's labeled on both sides. But if you're helping put stuff away, make sure that the label is facing out so we know what it is that we're getting. Okay, we've done that. In confined space, the other thing is, if we can do a confined space rescue without having to actually enter the confined space, and do what we call a non-entry rescue, that's even better yet. So we've got an extendable reach tool. With a carabiner with a little stay open bar on it. And then what we can do is, let's say that someone is down in a vault. Now, when you enter a confined space, the standard is that you're going to wear a Class 3 harness with a connection on the back, a dorsal connection. So, rather than us having to climb down there and put you in some kind of patient packaging unit, ideally, if you're wearing a Class 3 harness, we can take our non-entry rescue tool and we can actually take and clip it. Now we're on that connection. Now we can rig this up in our haul system and we can extract them. If they're in a horizontal pipe, we can take that, clip it to that, and then drag them out. So that's our non-entry rescue hook and how it works. So that's kind of cool. All right, next, Rescue 01.
So this is Rescue 01. It's kept at Olympia's headquarters station, Station 01. It's mostly structural collapse and trench. It does have confined space equipment on it, as we'll see, and it's got confined space and it's got some rope stuff. So basically, we've just got a bunch of tools. Up on top, there's just some basically safety stuff and spray paint for marking buildings, like hazardous structural markings for collapsed buildings or searched buildings. These are basically just toolboxes with construction equipment in them. Got nail belts in them. This is just a tool bag with extra tools and squares and pencils. We've got 4 nail belts with a hammer, tape measure, square, pencil, and there's 2 in each of these crates. So these are identical, just 2 kits for 4 builders. They also have airline in them with nail guns for doing structural collapse stuff. Toolboxes and this palm nailers for nailing. These are just a palm nailer to nail. They're air operated. You could just drive nails with them like regular nails. Work good in a trench. Anchor bolts, nails, bunch of boxes of nails back there. Mostly for structural collapse equipment in this one. Here we have a tripod back there and a Stokes basket. This is mostly our trench. It's mostly for trench in this compartment. This is all of our Paratech struts, and they are various lengths from 1 foot with your non-pneumatic down here to up to an 88-inch. This is a 55 to 88-inch. These are 25, 36, 19, 25. So they are air operated, as we'll see over there. Then there's some extensions. So there's 2 foot, 4 foot, and 1 foot extensions. So you can make an 88-incher up to 3 feet longer. You can put 2 extensions, not to exceed. On top, there's more bases, large bases for the Paratech. Big bases in some Raker Shore stuff that we won't get into, but that's Raker Shore for building a raker up against a tilted building. Up here we've got more Raker Shore stuff. Just tarps, and that's just tarps up there. Here we've got more air shores. These are Air Shore instead of Paratech. Operate about the same, just a different brand. They'll hold a little bit more weight. Here we have a hydrofusion, which is like an air shore, only it's hydraulically operated with a hand pump. So hose hooks to that, and you can lift up to 40,000 pounds with the two of them. And you can use them with these to make them longer, or you can use them with an extension. The air shores are all run by a controller, which we'll see over there. These are the bases. This is a swivel base. We have solid bases that doesn't swivel, that goes on each end of the air shores. Ropes for lowering panels into a trench, for trench rescue.
So that's where all your old ropes go when they are no longer good. They get cut up to be
Yeah, they're old rescue ropes, 12.5s. And then we also have some ropes for back there that lower the struts into a deep hole, which I'll show you over there. I've got one over there. Just some ratchet straps to tie bases together or tie stuff down, you know, multi-purpose. More hose for running air shower. Usually if we're running an air or in a trench, we could have up to 12, 15 air shores in a trench, and you leave an air hose hooked to each one of them, and then you just unhook it at the top and hook it up to the controller so that you don't have to go down in the hole and hook up each air hose. So we have a bunch of air hoses. This is the extent of the rope stuff. We have the main and belay line. Airbags that are air operated for heavy lifting, and then these are air shore bases for these, as those are Paratech bases. The Raker shore rails, these are long pieces of aluminum that you can put them together, make them 12 feet long, and make a brace up against a building for a Raker shore. This compartment is mostly cribbing. We've got 6x6, 3-foot long cribbing, and we've got 4x4, 2-foot long cribbing. And we've got a bucket full of wedges for tightening up things. This is a grip hoist. Yeah, a grip hoist. You feed a cable into it, and it works like a come along, only it's really heavy duty. And then the come along, the cable is inside of this tire. So the cable is stored in that tire, all coiled up. Some normal tools and chains and binders in here for tying down things. There's another air manifold here that you can use for trench, or can you use it for trench? No, that's not the right pressure.
Yeah.
You can use it for confined space.
Yeah. And then the awnings up as well.
Oh yeah, it's got awning on both sides, just like the other rig for our inclement weather. Got a hand truck back here that we can haul stuff down if we have to go a distance. So on this side, this is our confined space equipment in this area. We've got extra masks up there, a skid for rescue, just like on the other rescue. And then our air manifolds, our communications, and our Sabas in there. We've got 4 Sabas in here. This is a little file cabinet for permits and equipment manuals, cheat sheets on how to do shoring or trenching. And then our hoses, the rescue hose, then the other hoses are in there as well. Fan for ventilation. Air fans and air hoses, big expandable hose for ventilation. And then here's some SCBA bottles and some pickets. driving in the ground and securing stuff. There's a low pressure controller for low pressure airbags. Got low pressure bags up here. They're like airbags, only they're low pressure, but they get really big. So they're great big and they'll lift a lot still. Up here is more airbags and low pressure bags, low pressure regulators and hoses. This is some of our power equipment. We've got a metal cutting circular saw here for cutting steel. This is a 10 1/4 inch circular saw. We can cut 4x4s in half with that, or rip or make wedges. An electric chainsaw, just for cutting wood. And we've got 2 circular saws for cutting concrete. You can also put steel blades or asphalt blades in them, but these are concrete blades. We've got 2 saws like that, and then 2 saws like this. They're chainsaws that cut concrete. So you see the blade on these, they're really flat, and it's just an abrasive blade instead of a cutting blade like a chainsaw would have. These are big saws. You have to hook water up to them to cool the blade. Here we have our air compressor for running air tools. Then there's a water can back there. If you don't have the supplied air or supplied water like a garden hose, you can put water in that, pump it up, and run the chainsaw or circ saw with a pressurized water can, basically. Just some more tools. Sawhorses for cutting lumber, for shoring. We've got the propane torch, a acetylene torch, and a petrogen torch. And then up here there's electric rotor hammers for drilling holes through concrete. We can put a camera in through those holes, or we can make anchor bolts or stuff like that. This is just some PPE for cutting. It's got leather chaps and a coat. Extension cords. Some lighting up here, lifting straps. Here we've got a generator that will run skill saws and chop saws. In the trailer that comes with this, if we get a trench or a sort call, we have a trailer that is a 20-foot trailer, like a cargo trailer. Has all of our panels in it. It has a supply of 6x6s, 2x6s, plywood, and chop saw, stuff like that. It's just basically our little lumber store. Here we have oxygen and acetylene. This is the torch. You put that on this hand truck for cutting with oxyacetylene. And then this is the petrogen torch that runs on white gas. And a jackhammer. This is an electric jackhammer for breaking concrete.
All right, you want to show us the struts?
Here's the light that goes in the rescue that we have set up here, just so we have some light. It's battery operated, LED, run a long time, and extends up and down, so you can light things up, light an area. The other thing we were going to do is show you how to operate a couple of the Paratech air shores. So, if we were to shore up this door because a tree fell on the top of it or something, we'd make a base and a header. I'm not going to lift the head up there, but I know it's 5.5 inches. I take my toolbox, take my tool kit out, my tape measure, and I measure how big that is. So at 78, that's 6'6", less 6 inches, so it gives me 6 foot. So I go over and I grab an air shore that is between that'll reach to 6 foot. Now, an air shore,
You're gonna use Paratech struts for this? You're gonna use Paratech.
yeah,
Paratech.
Paratech, yeah, air operated Paratech. I'll put a base on. Base goes on the bottom. And this is you have to make sure that that clicks in. And this is up to an 85 inch. And so it's 37 to 85. So it's 37 itself. You also have to add in a couple of inches for that, because that's 2 inches there, and that's 1.5 inches there. But I know that if 58 inches isn't going to do it, 37 isn't long enough, so I'm going to have to add an extension. Wait, that has to go in the bottom, doesn't it? Because that won't reach there. They won't go together wrong.
So shouldn't, you wanna show how you can tell when you look at the
Because
holes?
I know that this is way up here, so that won't reach into that hole and lock it together. So this has to go on the bottom. And that will lock there. And then this will lock into here. Locked in. You want to hand me that air hose, Andy?
Actually, we'll just manually put the
Okay. So this one has holes instead of a ring around it. So this one, you have to pull it out and click and tie in. Then we put this over here, and we can actually put air to it.
Andy, do you want the pump?
For structural, we don't really want to push on it too hard.
No.
We extend this up. And I'm not going to put the header up there because we really don't have room for that 6x6 and I don't want to hold it. But we would put a 6x6 up here and hold that. And then put that, and then we manually tighten it up. So, and then there's a spanner wrench. You can grab this and give it a little bit more snug. So anyway, that is to hold up something. Works just like a trench would work, but trenches go horizontally. We'll show you that too.
And if it was really tall, we could use air to lift it, especially if we nailed the header on there. That's kind of heavy, so we can use air just to lift it, and then we
Or
finish
put
it off.
tension on it. You really don't want to lift anything and collapse, but you can put tension on it. Right.
Just to lift the header.
Oh yeah, to put the head, to lift the header up there. You can balance it there and lift it up. But you don't want to lift the structure. You don't want to move anything when you're doing structural collapse. So like I say, these go all the way from, we can reach up to 12 feet with these, and down to 1 foot. So to do a trench, we measure, that's 38 inches, Andy says. This is 36. You put the swivel on this end, and you put the, if we have to, we'll move the bench.
Yeah, oh yeah.
I'm gonna put 2x4 on this side.
Okay, yeah, if we put a 2x4 in there, it'll be good. Or I could get a 12-inch extension too, and put it in there. So, we would put a rope for trench. We'd take a rope and put it on each end, and then somebody stands on each side of the wrench of the trench, and we lower that down in with an air hose on it.
The purpose of this demonstration is just to show how the actual strut works. Not, we're gonna have panels in place and strong backs and a bunch of other things. But all the placement of these struts are done remotely from above. So Kenny's showing we'd have a cord,
Cord on both ends.
and we'd start with it small. And I'm
They
gonna,
don't like to go together when they're hooked up because it compresses the air. So unhook that, push it in, and the air comes out of here. And then there's a lock on there, lock ring. So You wanna hold that in, Andy, and
Yep.
do it this way? Or you can hold that in, I'll hold this in. You can hold that in, Andy, that's got a rope on it also. And then we'll say shoot on yellow.
So we're gonna feather it out first.
We're gonna feather it out, or feather on yellow. So I can make it go real easy. About like that. And then I would shoot it. It'd probably just move this bench if I do.
I set it 50, so it'll just good enough. All right, that's good.
Yeah.
So we
So
shot.
we shoot these to 250. And then you lock that
Release on yellow. Down.
down on yellow. And then I can unhook this on my end. We'll leave that end hooked up always because we can't reach that hose to get it back out. Release the ring. And then we'll just secure that up at the top of the panel.
So that's
that
the
it's
top
hanging
of the
there.
that's the top of the trench, and now we can start going down the ladder. We can have a rope, then put other struts in place. So
You can't go below your waist to, if so, the rule of thumb, just keep your waist anything above anything secure. So you can go down as far in the trench as the top of the lip, and then you can go down to the first strut.
Okay.
So this strut right now is being used in a pneumatic function, and when Ken demonstrated the other one, he was showing you that is mechanical.
Okay.
So,
It was pneumatically set and then mechanically captured.
Okay.
and then when this is tight, in order to get this to loosen,
I got to reshoot it.
he's got to shoot it. But if he shot it at 250, then he probably has to shoot it at 260 to get this loose. And then we've got a 6-foot hook with a spanner on it. So from above, we can take and attack this thing to try to loosen them up.
Because once we get out of the hole, we don't go back
Tighten
in to retrieve our struts. We do it all from above.
Nice.
We got to go in and pull the nails though, because we have to put nails in all this stuff to our panels to keep them, just in case to keep them from sliding.
So all of our SORT members get a helmet, headlamp. They have a travel limiting kit so that they can make themselves safe at an edge. It's at 30 feet of cord with a Prusik loop attached to it. Everybody has a harness, whereas you have class 2 harnesses, which are lightweight, inexpensive, super easy to get on. These are heavier, more expensive, sort of a pain in the neck to don, but it's a full body harness. So not only can we use them in low angle rescue, we can use them in high angle rescue. It has a dorsal connection in the back, so we can use them in confined space and in trench. And you'll notice this little tether. This is here so that when we go into a confined space, we have to have a tag line. But if we get stuck, we want to get out of there. And most guys can't reach the carabiner back there. So there's an extension so you can reach that carabiner. You could disconnect that line and untangle yourself if you were stuck. And then also for high angle rescue, they would have their belay line attached to their upper D-ring to keep them upright. So this is an example of a class 3 harness. And of course you buy them gloves and a pack, and then they've got a couple of carabiners, a set of personal Prusiks for going up and down the rope. The other thing I want to talk about is incident management and how that works. So District 8, you go on a call, it's snowing, heavy snow load, and you go out for someone saying they're stuck in their car, carport collapse. All right, sounds like sort of run-of-the-mill call, it's wintertime. As you arrive, or from the information you get, oh, this is like a structural collapse, send SORT. All right, so SORT gets dispatched. So we'll come out with the white truck, which is our support truck, as a command post with a bunch of equipment, and obviously it's structural collapse, we're gonna come out with the red truck. Now it could be you'll get out there and you'll recognize that, hey, with a chainsaw, we were able to cut through some plywood siding and remove someone from the car, done deal. But maybe it's more complex than that. Maybe it's a structural collapse and you really can't get in there. So when we arrive on scene, one of our members is assigned as the rescue supervisor, one of our members is assigned as safety, and then your IC, be it the battalion or your assistant chief, if they're still the IC, it's their incident, we then are just going to take care of the technical component of it. And, hey, what can we do to support you? Well, hey, We don't know what's on the other side of this wall. If it's a wooden wall, we can use a saw, we can get in there. We've got a search camera, which is down here. Sorry, Ally. This is a 12-foot extendable wand with sound, color picture camera. So we could cut a hole in that wall, send this camera in, turn it back and forth, up and down, and see where there's a victim or there are hazards. Is there a gas line or something like that? We can stick a tube for an air monitor in there. If it's concrete, we can breach that. We've got a concrete coring tool that we can use. So we're going to support you on that structural collapse. You're going to support us because, hey, there's only so many of us. We need tools and equipment brought over. Hey, here are some mauls. We've scored the concrete here. Start smacking at the maul to gain access. You know how to use ladders for rescue. We did that, a moving ladder. So maybe you've got someone up on a roof. You're going to package in that, and by the time we get out there, we're there just to help receive that because you don't need the technical assistance. But the way we're going to operate is we're going to assign a rescue supervisor, technical rescue safety officer, structural collapse or a confined space. If we have a large team response, we'll also assign an entry officer. So they're going to be right at the edge of the hot zone, warm zone, hot zone. They're going to coordinate who goes into that space so the rescue supervisor can concentrate on some of the other aspects of the rescue. The train rescue obviously was probably the most dramatic example of that. A lot of moving parts, and unfortunately then we've got other people trying to do their own thing, so it makes it difficult. So most of the incidents we respond to are probably the chutes falls, people that fall, car over the embankment, car off of cliffs, things like that. Sometimes there's a choice where it's access and it's extraction and extrication and then patient movement. And obviously you've got some of those same situations out here. And we look towards maybe training in some more challenging terrain in the future at some of the other parks that you've got in the area. So I think that's it.
So you guys are on scene, you have everyone set up, you're starting the rescue. Who does IC talk to?
So the IC would talk to the rescue supervisor.
Okay.
That's going to be the lead person and we will then talk to IC. Hey, our guys say, it turns out there's 4 patients down here. We're going to need 2 more medic units and 2 BLS transport rigs. IC is going to do that rather than have 4 other people calling TCOM asking for that. So the IC is going to be the main focal point. Hey, we need Puget Sound Energy for a bucket truck for access to this area. IC will then call it for that. We'll let the IC set up staging because all of a sudden we're going to get all these rigs and this is your district. You know what streets you can turn around on, where you can't. And if they don't come out, hey, we're going to probably need a staging officer pretty quick because we're going to have a lot of units arriving in a short period of time. The first sort call I went on was a well rescue in Mason County. I drive out there and it's up a steep, long driveway. I get up there and there's a rescue truck, a small vehicle, and it's right in front of me. I'm like, hey, can you move that truck so we can get vehicles moved? The guy goes, that truck ain't moving. And I'm thinking, this is nice. This is how this is gonna be for this incident. Like, okay. Well, I find out 45 minutes later is the drive line dropped out of the truck when they drove up there. This truck ain't moving because the drive line dropped out. Oh, all right. He's just telling me that that's where I'm parked and I'm not going to go anywhere. But hey, the most information we can get would be great. In this case, we couldn't bring our rescue truck up the driveway. We had a hand carry. So, especially if it's a longer driveway and it's a technical rescue truck, confined space or a trench or a structural collapse, let's get the manpower staged at the beginning of the driveway, and we'll get a utility truck that we can throw gear in, or engine 81, engine 83, where's your personnel? All right, you 3 guys, you've got all of our confined space breathing apparatus. We're gonna give you the single boxes, we're gonna carry those down. And then we'll have a guy down there, all right, stage all that equipment right here, so it all ends up in one place. We try to label all of our stuff, and if you take stuff, we'll try to tell you what it is, so that you know when you're going down there. So, I've learned already, if we're going to have to pack stuff in ways, and I'm going to give people stuff, I'm going to take my notebook out, engine 81. 2 3-inch-foot ropes and all the rigging pulleys, so we kind of track that stuff down later, because you might not realize what you have when it's in a pack or something like that. That gets frustrating when you've lost that and you need that. And then, hey, one of the things our guys are pretty good at is being able to improvise, because that's what happens quite often. Any other questions?